I have one, but I haven't been able to play with it because it's a frequency I'm not supposed to use without a
You got the
license in the
Europe,
US.
did you get the European
Yeah, because I
one?
bought it in Europe for cheap. Yeah.
I ordered it and they sent me the European ones.
And so now you can't until you get your hand
Well, I went
license.
ahead and ordered the 915
Yeah.
version,
Right.
the US version as well, and I've got them on hand. I just haven't used them.
Hey, it works.
Rock and roll.
I'm curious what the distance
I'm
of these
terrified.
things really are.
I can see Dante now.
When you go on the
The
internet,
network's up.
line of sight, with the crazy distances on those. Hundreds, you know, like 100 miles or something like that. You know.
Do we have any?
There we go. That's what you want.
What do they call those?
Okay.
Feeders, gateways, lower gateways, or what do they
Oh,
call
we
those?
lost someone again. All right.
Yeah.
Minute we
Just
just
start without.
We lost
Let's
something?
go for it.
No, we lost a person. No. You know,
His-
no
his
real,
first
no real
kill.
people, just cops. Yeah.
I was curious if I could talk from like
Alright.
up in the tower to my house in Jenks. You know, it's almost line of sight.
Brothers and sisters, I have a mission for you. You've been thinking all this time that you knew it all. Nothing's got to change. It's all going to be the same. I'm just going to work on my little Twinkle Linky Blinky Lighty project, and I'm going to do it in C++ until I calcify. And that's it.
Amen.
And there's never going to be a change again. Because I got 8 kilobytes, and who needs more? Only the devil. Well, I got news for you. We got 32-bit embedded all over the place. If you ain't moving fast enough, you're gonna be swallowed. And I want you to get ready for the future. And there's lots of different futures. A multiverse of futures. Some people's is talking Node MCU. Some people's is talking about this MicroPython I'm gonna talk about tonight. Who knows where it could go?
Amen.
Who knows how proprietary or not? Who knows where the future lies? But I will tell you, more than anything else at all, we all know what we really want. Lights that blink in weirder ways. And I bring to you, ladies and gentlemen, high-level blinking.
Tell me what you want, what you really, really want. Tell me what you want, what you really, really, really want.
Hey, we're gonna get cut off with that because it's a recognizable song.
This is what
I'm
happens
just,
when give a
you know,
face
this
off.
is why you have to make up your own songs. So, yes, how MicroPython can fit into our bright enough future. So, this is so as you can see, I have 2.5 slides, but most of this is actually going to be the notes. So, and really, it does come down to what I just said in preachy voice, which is we are all very used to what we've been working on for about a decade now. If, you know, even though this is a newer version of one of the lovely Arduino units, it's still, you write it in what is essentially wiring, which is a permutation of C++, blah, blah, blah. You only need to hold a certain stack in your head and you can focus on the stuff you know of that, but in turn, we have our 4 billion hello worlds. Here's mine, squeeze the light, and the more you squeeze, the brighter it is. 3D.
Does it also make the
What's that?
noise? Does it also make the noise?
No, that's me.
Oh.
That's my job.
It makes you make a noise.
Exactly. But so we've gotten used to this, and of course we know our code for this. So I might as well pull that up while I'm at it, because why not? But more importantly, we are all very familiar with. Oh dear, this means I'm probably gonna have to do this in old school. I just upgraded Arduino, which was a mistake. Nothing wrong. I just lost all my settings. So because Arduino. But one of the things is we've gotten familiar with the libraries we deal with and all these pieces, but we've also gotten familiar with that semi-low level way of thinking. Now it's going to be hard to read at this res, but you can see this is the code for what I was just showing, where I'm thinking about, okay, set up that the pin is on 11, know these hard locations.
You can actually increase the size of the font.
Can I do it just like with a,
Yep, should be.
nope, not like that.
Should be in view at least.
Yeah, let's talk future during my presentation.
Hey, where was that?
Yeah.
I think it was like under file preferences or something stupid like that.
Maybe I'll just go find this. Why don't I find the file and load it in a
Yeah, it's in
different.
preferences, there's an editor font size.
Oh, but that means you have to restart it. Okay,
No,
well,
no, it's on the fly.
is it now? Oh, that'd be cool. Font size
Give us 20.
24. Let's see it. Ooh, a little bigger.
I can almost read it.
Yeah. But so here we go. Ba 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 ba. void, set of void, all these things that we're familiar with if you're already coming from the C world. And many of us, if you're not just coming out of electronics, being an electrician, you're already going to be familiar with this because you'd been dealing with this going way back. And it's true for me too, because even though I'm vaguely of the younger set, I'm 43. I was a Cabana boy for coders 20 years ago. I'm familiar with this language. So I'm familiar with, okay, I'm going to do, for example, this line where I say, okay, I know my readings are coming in as in 10-bit, and I need to output them as 8-bit. So I just make the mapping from 0 to 1023, turn into 0 to 255. You go drop the zeros. That's that. That's what that line does. We know this stuff, and all of this familiar with that. Most of this is about output for extra if I want to make sure things are working, and how to make the notes accordingly. But we've got a generation of kids coming up who are already learning other high-level languages. And technically, C++ is a high-level, mid-level language. It's great for writing drivers, which is what we're doing in an embedded world. And it's also why we're more comfortable. We know you've got these tight spaces. How do we think about them? Well, we've gotten used to thinking about them when you know a lot more about I'm making this size, and you're not letting an interpreter do the thinking for you. This has become the crux. So are we now at a point where we've got the bandwidth to do this differently? Kinda. And I think that's going to be the point. One of the other points is I did not get to finish my actual demo module. I'm going to show you somebody else's because I've decided that the important part is actually making a purchase. We'll get to that in a moment. But let's start with what we're looking at. We are looking at, as it says here, so it's not an Arduino. So here's the thing. We're going to start by looking at what I had sitting around in my house. I have here an ESP12. Now, these are cheap. Again, you could even, if you really want to go nuts, you could even start with the very basic ESP01. In other words, the 8266 that everyone's familiar with. However, those only have, I think at most, half a megabyte of memory, which in Arduino world would be ridiculous expanses of memory. But in this world, not so much, because this thing isn't actually meant to do all of these extra pieces. It was designed to be a Wi-Fi system. That was its entire job, and that just requires full 32-bit to process various things that 8-bit doesn't quite do as well. So, oops, sorry. And so, oh, I'm sorry.
Yeah, perfect.
Have a better one. Hope it close well. We've all been there. And also, so you think, well, okay, right. So you've got the problem of that all of these things that we don't have to think about when we're dealing with, say, Arduino or a lot of these other pieces, because they've been around long enough that we've ruggedized them. We take a look at your basic Arduino setup, and it's not our basic anymore. This thing has 2 processors, but it's also got capacitors and parts for dealing with voltage. There's a voltage regulator on board. There are 2 polyfuses, one for each of the main chips. This thing has a whole bunch of stuff so that you can bang it around and probably even drop it in water, and you're not really going to, it'll dry off in a second, you'll be fine. We're not quite there with these. And that doesn't sound like a big deal until you start trying to actually do things, because what you're expecting to do is, again, a step up. If you're not familiar with Python at all, let's raise a hand. Who here hasn't either written or at least reviewed some Python code? Okay. So Python is an interpreted language, so it's high level. And it was developed, try not to get too political / emotional about it. It was developed by this guy, Guido van Rossum, who's from the Netherlands. He named it for Monty Python. And his thinking at the time was that there should be something simple enough to hold all in your head and still get some stuff done. Now, keep in mind, he's kind of working in a rival track to the Perl people, who have already got some bandwidth and also have the hold on people because of both CPAN library, this huge collection of stuff, and the regex capabilities in Perl. So for the longest time, you'd see people who are Pythonistas, and all of us Perl mongers would look at them like, you're nuts. What's with the, wait, white space is significant? I'm done, bye. and that would be it. Exactly, because that's tarred. But funny thing happened. One, the inventor of Perl decided to do the Chinese democracy of releases in coming up with Perl 6. It took 16 years to come to Perl 6. 16 years. And during that time, the web changed dramatically because we're talking about a major, I mean, let's face it, the plans for it started before 9/11. I don't know if I even have to go that much farther in it. But because of that, Python suddenly starts taking off because Perl isn't keeping up. Its community has lost touch, and there's lots of other reasons for it. And now, thanks to REST APIs and all these other pieces where people have been building things for this thing because it was more comfortable to build a dictionary, next thing you know, well, Python's dominant, Perl's not. But there is one extra advantage about this, and I hope I'm not losing everybody. But the advantage when it comes to that is that Python presents pretty parsable code just from a high level by forcing some of these things, but also now having available things like linters so that you can just go and clean, make the computer do the cleanup for you. Well, we're losing everybody. Oh no. I'm losing everyone.
It's for food, it's a good reason.
Oh, okay. There's food? I like food. Food goes well with food. But so let me pull this up. Okay, yeah, right. I got it right here. Here's a quick little sample of nothing, but it's, oh God, it's really nothing. Okay, but, okay, there, a few lines. I've got more than that elsewhere. But you get the idea of that what would normally seem like a bunch of bondage and discipline doesn't turn out to be, because it means someone coming into this for the first time can, even just looking at this, pick up exactly where I left off, going, oh, R is call this requests import get function, and then do this thing, and then I'm going to R dot whatever to make a call. This is part of something to reproduce what I was trying to do in a shell, but takes forever because it's a bunch of curl options. And it's like, oh God, I don't want to type that a billion times. A programmer does not write it twice. Yeah. Let the computer be the obsessive. I'll be the compulsive. And in turn, so, all right, simple enough, but what this also means is you could think more about the theory behind the stuff you wanted to do. You don't have to get as hard into the root. So this sounds optimistic. All right, great. We're starting to get to tools that you could just about squeeze some kind of interpreted kernel onto. And the funny thing that now strikes me as I say this is, I'm surprised they didn't start thinking about Lua for this. Okay, and I will go there before we even get to MicroPython, and I'll tell you why. It's another interpreted language. It has a similar age and history. And its history is, however, its foundation is very specific, unlike Guido, who was just bored. And yes, there are a surprising number of people in both the Netherlands and Belgium named Guido. I do not know why.
Lua, I know. Is it like Lua?
What, Lua is, what, Python? Kind of. It's much closer. What's funny is it's closer to the Perl side of things, but if you've dealt with Lua, you have a good idea. Now, with the advantage with Lua, so you know it, and I bet now I think the rest of the room doesn't, but now we've got something we've got a Granfalloon here, is that Lua, for the rest of you, was developed in the 90s by Brazilian developers because Brazil at the time was so broke. They were like, look, everybody who's writing code, you got to build all your tools in-house. We got to eat national dog food because we can't afford, because if we're paying anything to licensing to IBM or anybody else, we're going broke. We want to start being our own powerhouse. And it worked because of Lua in particular. Lua is the word for moon in Portuguese. And these guys were Solaris admins and stuff, and they were doing all this work, and they found they wanted something that could, well, let them get more done for configuration stuff on their Solaris environments. And so they're already paying licensing to Sun back before the horrors of Oracle. Oh, hey, pizza. But this provided this. So for the sun, so they've got the moon, Lua. And this language, it's very simple, but one of its biggest advantages, besides being able to use modules from C, much like when you're in, say, Jython and you can use Java modules. We won't get into that right now. But and it's also outdated, but is that because of this, it's very easy to run a tiny interpreter executable. I mean, I'm talking, it still fits on a floppy drive with plenty of space to spare. Like we're talking a typical one for a Windows machine today is 527 kilobytes. So fitting something like that on something that's got,
They've done it. There's actually 3 different projects that run Lua as an interpreter on embedded systems.
and I'll bet you it works pretty well.
Oh yeah, it's,
Oh, yeah.
it's
So that'll be another presentation. Yeah, because
it's
that's
8
actually,
kilobytes. The interpreter is 8 kilobytes.
that's brilliant. Ah, that's so smart it hurts. All right, now we know what the future presentations will be about. But this does go with the idea of it, that, ooh, veggies. So, but the point is that, yes, there are certain things that are going to lend this stuff more to others. Now, the thing about Python is you tend to be loading modules, even something as simple as what is inherent in Perl, regex, is kind of a module. And it's the RE module, but it's still like you're making these slightly longer calls. Perl mongers are so proud of what we call Perl golf, the idea that you could get code that's so densely packed that review can never escape it, and that it will never be read again. It's write-only memory. But funny thing about when you do this in Python, you're still going to end up with 3 lines of code. But then the 4th line will now tie together one API to another. So you've got a sudden advance like, okay, I got this overhead and no overhead here. And someone will be able to look back going, oh, that's what you were doing. Oh, okay. Yeah, we have to replace that API in this one, but that just means we sub these 2 pieces in. Oh, that's easy. Good. So, what does this deal with in terms of the embedded world? Well, we're wanting to do the same kind of thing. Squeeze the light, make the light, squeeze the thingy, make the light go. Very basic input-output stuff. All of your kinds of things. So MicroPython exists. MicroPython is an attempt to do a lot of these things. It was developed more actually to promote the Pi board. The board itself. Now, this is, and here's the great thing, SparkFun has these available with the headers, because there's a lot of headers, but $45. However, if you buy it at Amazon, for some reason, it's $72. Oh, I just got a note from Kaibo. Huh. Anyway, but, well,
Can you pick your phone up? It's really loud on
Oh.
the microphone. Sorry.
sorry. So, apologize for that, but, and as you can see, a lot of this is about so much of this. So let's take a look at some of the specs, because it's easier for us to start thinking of this as a hardware thing. I know I'm almost losing people by not. So here's the hardware. You're looking at an STM chip that is essentially some ST production of something on the Cortex series. I forget. Oh yeah, it's a Cortex M4. So there we go, 168 megabytes. This is not the one, obviously, that I've got here, but it does have certain advantages. This has a megabyte of flash ROM and 192 kilobytes of RAM. I'm not sure whether this is Harvard architecture or not.
That one?
Yeah,
I think so.
I would assume so. But it's already got. It's got micro USB. It takes a micro SD card. You can see the dimensions on it are fairly small, so you can pack it into a lot of things. And
Bootloader's also open, so if you decide that Python's not your thing, Node
MCU
well,
or
I was going
Lua-
to say Espresso is the one that they use.
That's a nice, yeah.
Yeah.
So you've got a bunch of options you can fall back with. Thank you. And another point with this is low power. So one of the great advantages, so we still have that advantage, that if you're not doing a lot of heavy stuff, we've got stories of people running them on like a battery for a year. Wicked!
There's CoinCell ones too.
On year 2
Oh yeah,
of a Wi-Fi or a Bluetooth-enabled light switch button that got stuck on the wall because we don't have neutral lines in our house, so I had to use a spare button.
could you hand me a slice of pizza? I'm like famished here. So I will somehow integrate this into the presentation. Let's assume this slice of pizza represents the processing you need to do. Here it's going to have to be small and tasteful. Well, as much as this brand can be. But you'll notice you're getting the band, and much of this is also available on a lot of the other tools. So you've got a 10-bit ADC not enough to do audio, but more than enough to do a surprising number of things. SPI, I2C. It even has a DAC to go back out. And, of course, can't have nothing without serial, UART. So, yes, that means you go through all the same things you would with an 8266 of first time around setup. And that is a burden you don't deal with Arduino. You don't have to do the, okay, first time around, I gotta talk to you somehow, probably through serial, and I've done presentations about this before, that yes, even though I've gotten more and more comfortable with it, it still feels like reinventing the wheel every time. Now, with that in mind, though, you are giving me such a look.
I'm kind of confused. You say we have to come up with a way to talk to it the first time?
Well,
I mean, you're
so
talking
let's
about...
take, well, not so much the Pi board, but say a regular one off the street.
Right.
So let's say this is even one of the later models with 4 meg
Mm-hmm.
of storage. All right, you got an antenna, you got your 4 meg of storage, it's all there. Do you know what's even going to happen the first time I got to power this? What do I got to do? I got to wire up the 4 parts. I'm going to make sure there's some voltage.
Mm-hmm.
It doesn't sound like a big deal unless you're people who've already been dealing with Arduinos and they're used to just plugging right in. That problem isn't there. So for all of us who are hardware freaks, no big deal. Run your 4 lines, we're done. We're going to find out. And then what? Then I still got to watch the serial to find out where is it trying to talk to. Yes, it becomes, because remember, when it first starts, one of these first starts up, it starts up in a broadcast mode. It's trying to be the station.
Do those not support a ISP style flash?
I'm not
Can
sure.
you not just JTAG them and reload your settings?
You know, I haven't even, because I didn't get to have the time, so this is where I apologize.
Well, most people don't have JTAG.
No, and I
No,
do.
but I mean,
I'm
even
lucky.
with like
Yeah.
preloading a bare bones style Arduino, you still have to JTAG the first bootloader.
Well,
so-
most people don't, because most of those come pre-flash.
Come with the OptiBoot chip.
Right.
Yeah.
Yeah.
But that would be like comparing the module he just showed off,
Right.
saying like, because
Right.
yeah,
You can buy, so for example, so if we want to make it apples to apples, and we should be fair. On the Arduino, at least on the old school ones where it's still the PTH and not an SMD, that chip, we all know it, it's the, the AT Mega, sorry, AT, no, it's
Yeah,
not.
18 mega.
It is an AT Mega 32.8P. In particular, we all know the 32 stands for 32 kilobytes of storage and 8 kilobytes of, well, where's it 2 kilobytes of RAM? Oh, now I don't remember.
it's
I think the 8's 8-bit.
Right.
Oh, that's right.
Right, because the other ones are smaller size. But one of the things that's in there is if you buy one on the street, if you buy it straight out, you can get one, even one of those, at least a couple of years ago, it was only like, $2. No big deal.
50 cents
Oh, it's now
now.
even
Yep.
cheaper, of course. And they're ridiculously rugged. I mean, you can run them in temporarily at up to 105 Celsius. At a regular condition of 85 Celsius, which means you could tie one of these into a coffee maker and have it poorly heat synced or not heat synced at all. It'll be fine.
Yeah.
It will totally be fine.
And
it
they're
will
pretty
now.
tolerant to voltage changes.
Mm-hmm.
I mean, even the
crazy
new,
rugged.
even the newer SMD ones are pretty rugged.
Oh yeah, 'cause there's even less to worry about. But the point is, now that the prices are even lower, but if you want OptiBoot already on there, just that 1/2 a kilobyte of information. I remember this price very clearly, $4.30. So even if it's half that now, you're still paying for somebody to have done that bit. This isn't necessarily there. You don't know what's going to be there when you first power this up. You first power up an Arduino where the chip's already there, you know what's going to be there. But again, apples to apples, it's not quite there. That's not, however, as we point out though, the great thing is once you get through that annoying first mile part, which is the first mile of all of the stuff we're doing here, and you get through the other thing of finding out, well, okay, I've got what looks like it says on here, it's an AI Thinker 82 blah 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 mod. Okay, what does that mean? Well, it turns out this thing was already put onto a, thank goodness it was, because I don't have the right, something so that you can actually fit it in regular breadboards. But all the information that you need about it is underneath, so now you can't read it. How are you going to get that? You got to power it up and get the system info, which means you've got to get connected just to know whether or not you have a 1 meg, a 4 meg, or half a meg of storage to work with. That's a pretty important.
Didn't know they had that many versions.
And that's the problem. The 12 alone, which has now become fairly common, so this one is, I believe, a 12F. And it gets really weird because there are a lot of them that are 12Es, and you can tell those because they've got more ports, but often the 12E also has a USB, so you wouldn't even ask these questions. But that means you're also expecting USB power all the time. So you can't just run it off of some rail. This, I can run off a rail. It's 16 pins. I have only, all of these things that, that you figure out, but I've got to get that info first. So it feels less like you're powering up a Commodore 64 and more like you're powering up an MSI. You don't know what you got. It's your first time around. Yeah, at one point maybe somebody knew, but the problem is the companies that manufacture these, they're all in Shenzhen. When you try to look up the specs, you can look up the name, but it's only going to be in Mandarin Chinese.
And that's what Google translates.
Well, it'll be in Mandarin Chinese.
Yeah, but
if
it's
you're
also
lucky.
it's also screenshots.
Yeah.
So can't translate a picture.
And that's why I have a daughter that is in her 5th year of Chinese.
The only reason.
I don't know if this scales.
I've got one that did the dual language Spanish program, and I did one that had the dual language Chinese program at Jenks.
That's-
I figure I'm covered no matter who wins.
They teach Chinese in Jenks. Wow, they
Yep.
really are planning for a future. Wasted my time on French and Russian. Cold War, over. Bummer. So it's never over, but it'll be over again anyway. So yes. So, kind of sum up some of the stuff we talked about is that Pi is booting so that there's this MicroPi and MicroPython that's able to boot a chip. It becomes kind of an RTOS. You actually have enough bandwidth going on with the chip and enough speed that you can have memory management and a few other things that you cannot have on an Arduino. But for some of us, that's kind of what we like about them. There's no chance of memory management. There's no, you know exactly what was happening, and it's kind of the joy of it is that you know every instruction and you learn it, whereas this is kind of taking you back to that removal. Where's the fun in that? Well, it depends. And so it leads to questions of what is the difference even with MicroPython itself versus regular Python? And there are differences. Even in some of the simple stuff, there's even a page, I'll have to dig it up. I mean, so the firmwares are no problem, but you got to know which one you're putting. Are you putting it for the right machine? So yes, here's a bunch of them for various boards. But you've also got, do I have it here? Switch callbacks and interrupts. Yes. So one of the, getting a prompt. So now, if you're familiar, and I know much of the room may not be familiar, but if you're familiar at all with the Python prompt, that's what you'll get. But you'll also have to do certain amounts of extra tokenization because they couldn't fit it into the version of Python. This sounds like a minor point, but if it means that you've definitely got to lint your stuff before you upload. Good news, your upload is through Wi-Fi. So actually getting it over stops being, where's my dongle? Oh my God, where's that? No, it's Wi-Fi. If you're on the same network, you're done. And it's just a matter of adding those pieces. So you get some idea. So this also means that you're addressing things through libraries and you can just get comfortable with how that works. And it also means you can do emulation. We have some level of emulation when it comes to Arduino, but usually why would you bother? You've probably got 5 of them sitting unused, some of them still in the box, because you're like, well, it was a sale. It's true. A micro, you can get those micro ones and they're $8. Yes, they don't have anything soldered onto them yet, but they've got a USB port, so you're done. You're like, God, Bob's your uncle. Put it on a breadboard when you got the time. But so whereas with this, you've got to start thinking about these questions of setup and first time around. Now, in the past, I've done presentations talking about, we can all laugh right now, Intel's attempts at these things, such as the Edison, which is beautiful and done. And that's too bad, because it was nice. But it also led to the question of who did they think their audience is. With MicroPython, the audience is kind of us and kind of not us. And this is one of the conclusions I've come to from some of the reading. Yeah.
Wasn't the Edison didn't it have a full operating system on it? So
It runs Yocto Linux.
right, and
Yeah.
that's a huge difference between this.
Oh,
where
yeah,
there's
no, it's a full-
operating system.
No, you can do an RTOS, but you're still kind of in that little world. But that's the same thing as like a BIOS on an old Spark box,
Yeah.
which was running Forth. This is actually even more complex than that. So you do have the beauty of it. So who is the target audience? As you can see, I've got some theories on it. Upper class students in electrical engineering to practice IoT benchmarking. If you've already been thinking, you already know about your voltages, you understand, if you've been dealing with AC current and doing your own math on that, this is a walk in the park. Because most EE students these days have already been taking computer science classes, because those are the gut classes. They're like, oh, when I'm done, I'll at least have a job. No one's going to need my electrical skills, but I can go out and do this. Yeah. But the other thing is one of the big reasons people have come to Python at all. Electronics folks who want a RESTful response from an embedded device. This is not a small group. So one of the reasons I don't have a demo for you, and instead I'm going to show you somebody else's Neko Cat, is that I was away last week in Atlanta, ATL living, for training on ElasticStack. And whatever you feel about that, and it was an interesting education and kind of overwhelming, and lots of JSON, lots of nested JSON. I had some nightmares about JSON. It's like, it's all nested. Why? It looks like the Grand Teton for 2 pieces of data. What's going on here? But all of that aside, it's kind of interesting stuff, but the real thing is, the point is, this is the kind of infrastructure for gathering a whole lot of data and getting you out to some level of analytics. And it's not even full machine learning. They have a machine learning module that is not really machine learning. It's not even doing some of the stuff that we're covering at Tulsa Data Science to learn more about how to go through those kinds of iterations in teaching a machine. And yet it's still able to gather all this data in giant chunks and sort it all out. Now imagine you're handing it data straight from the street. Well, if you're already gathering it on a high level, and in fact, if you're already gathering it so that it can be processed out by REST data and you can talk to it in REST format, you're not even going to be worrying about, these are things you can't even think about with an Arduino. With the Arduino, you may have some of them parked in various places. You still got to connect the information back up and then have a machine that's going to process that. And it's gathering from serial and doing all this. With these, you don't have to. You can actually set, now cramming it in is going to be a question, but the potential is there for at least a tiny squeaky version of building your own REST API that talks back. Now, you might be saying, yeah, at 4 megabytes, maybe. But we know that 4 megabytes is not going to be the limit forever. We already know with the ESP32s there's more storage. We also know, and that's the next generation, the Espressif. In fact, if you later on, if you want to speak on that, that would be awesome, because you have the experience and I didn't. But
With 32s now.
oh no, but one of the big benefits is we can start thinking about our Internet of Things as directly accessible, or in other ways, especially now that there's thoughts about how to standardize local meshes. You start getting the idea of gather this and push it out, but even the things that gather it are going to gather in standard forms. There's almost no processing. So all it is about getting the throughput. On slow things, if they've already got your answers the way you want to read them, half your work's done. And this means you can actually start putting things into a home with a control, with your normal controls that you would have for security, that you would do in any network, instead of having to do a heavy level thinking, and have these things talk to each other and give you data and address directly, so that you stop thinking, how did I do this again? And you're like, oh, no, it's just the same thing I'm doing in Postman when I'm trying to talk to Imgur or anything else.
So
Yep.
you're saying that you can do security on the chip, or you're relying
I don't know,
on the
but
network?
now you're not really, so I'm going to have to go with a no on security on the chip so far.
They actually have SSL
They do.
crammed onto the damn thing. They're
Can
pretty
they?
damn proud of it too. Not on the MicroPython version necessarily, but on that chipset. They do.
Oh.
I was going to say, on the MicroPython you were showing off, you were accessing an SSL page.
Oh.
Do you see that?
No, I'd actually had not gotten to that part. Let's
Go back to the code you were writing there.
That
No,
may not have
you were
been-
writing the...
Oh, the little thing that I had up?
Yeah.
That may not have been for the MicroPython.
No, this is for regular.
Oh.
I'm talking to us. That's a server. That's running
Okay.
my Nagios knockoff for work. But the point is, this is not far fetched, and it's not actually the heaviest stuff that could possibly be going on. So why would we think about this as a future? It may not be for teaching, like we say, there are also other ones. There's Node MCU for people who are more comfortable already with Node.js. As we said, there's a Lua one, there's a bunch of these. But let's take a look instead of just getting, because it's easy for us to get caught in the theoretical. Let's instead look at the beautiful future of the cat that said hello.
That looks dangerous.
Oh, it's totally dangerous. Oh my God, nothing but. We all gonna die. So, lucky spinning arm display. Yes.
You keep saying Node MCU. Node MCU is the Lua one.
Is it the Lua one?
Yep.
Oh, even better.
Esprestuino is the JavaScript one.
The names don't make sense then. Oh, great. I'm really doing well with this. But here you go. A lovely embedded device that waves hello Python, because now this started out as, look, you got your bill of materials. This guy did a great job of presenting this. There's your NekoCat. He had to hollow it out and do some stuff and replace he didn't have to replace the arm, but he had to replace the gear work because he burned it out so fast. Guy shows all work. Look at this. He replaced it with also it's much easier when you've got a wooden block, even if it's balsa, to put everything on. There's the arm, and you can also see he puts in 5 LEDs. So, everybody's favorite part, the soldering. Tiny board and soldering. The look of love, it's in its hand. So, Dr. Evil's being built, and how can you say no to that? All right, poop. I mean, come on. My son would be in love. I'm not going to show him to him yet, but soon enough. But there it is. Oh my God, it's the exact same chip I've got right here, except that one's got the USB and mine doesn't. Simple connectivity. But it also means when you write these things, you don't have to stress about stuff like, how am I going to fit all of the words in that I wanted to say? You just type them. You just hand it off the info. So he even chose, now this is where, for example, in this case, he actually did a character set to make it so that letters would show up a certain way. So essentially this is mapped to ASCII. Not quite, but close. But you can see, and he didn't even have all the notes on there for what they are, but he does note the custom symbols: heart, python, aubergine, poop, and cat. Can't believe aubergine got in there. That's for those of you not familiar, the aubergine is the British word for what we call the eggplant. For those of you who haven't used emoji, I'm going to stop right there. Those of you who have used emoji, I'm going to stop right there. It's purple. It's got a head. And so, but here we go. Look at this. Very simple definition. So if you're not familiar with how this looks, heck, why not? Let's just copy and paste. Not because we're trying to steal, but because we're trying to present. And paste. And I'll just toss this to shebang. I don't even know if this will work right. I don't care. It's old Python 3. Now if I try to save it, it'll actually render it correctly. Yeah, okay. .py. There we go. Colors! Polygons! So def means we're defining a subroutine. Everyone knows that part. So, and in this case, it's really clear, even just picking this up straight out, that we know what we're looking for. Okay, I'm going to get a message and a length. It's going to deal with the order if it turns out this is a glyph, it does these tricks. So like we say, the aubergine, all the other fun stuff. Then append that to whatever's going on, so it doesn't actually have to clear. It then takes the result, blank. It instead gives the blank. It puts it out, and then it puts out what you've got and puts a final capper of blanking out, so that the message goes, returns the result, and hands that back. Boom. The magic's there, and it means that if you're used to thinking in terms of matrix math, you've got the matrix right there. You're saying, okay, this array's got 5 items. And arrays are the fundamental building block of Python. So having something like this means it knows how to optimize already because you're using the way it likes to think. Obviously, this is not the case when we're dealing with our C++ code in Arduino. The array is not fundamental. I'm not sure quite what's fundamental. Sometimes pain, sometimes...
I think the pin is about the only fundamental thing in Arduino.
Yeah,
But you
that's
gotta
true.
remember-
That's fundamental in the hardware and then in addressability, but I don't...
The language, I mean,
Yeah.
the notion of how to address a pin is fundamental to that language.
True,
That's
yeah.
what makes them so easy to work with.
Yeah.
You have to know math and other stuff to do other stuff, but turning the pin on and off, that's very simple.
Good point. Thank you. Yeah. And it is one of the initial conditions is define these pins and go. So this gives us an idea of what kind of stuff we'd be looking at. We can do all the kinds of fun things we like doing. I mean, we all like breaking stuff and putting it back together again. But, so we got to see this guy with a Maneki Neko. I finally learned the actual name of those things. It's a Maneki Neko. But, so because of the USB connector, you're dealing with high-level things. But I will say, I still love my Arduino, and I'm sure we all do too here, because it makes the classroom experience far simpler. You don't start with MicroPython. When you start an Arduino class, you start somebody with essentially something that you're just changing from, I'm going to set up a timer to make these electronics things happen, to I'm going to type up what that would have done, and then make that happen. The Arduino's job has been to turn into software, well, really firmware, but instead what had been chips, without having to think about it as chip logic, and instead thinking about it as, what do I want to do? You teach algorithms in a very simple way to a large audience. Because when they're done, whether you've got little kids, bigger kids, full-grown adults, whether you're starting with artists who've never touched one before, or you're starting with senior citizens, it doesn't matter. You're presenting, you want to do a thing. That's what we're going to do. And that all of your teaching methods can focus on that. When you're starting with Python, you're thinking about programming. Nothing wrong with that, but it does mean you're probably going to have to start out teaching Python and then get into it. And so while the Arduino is using a lower level language, the language itself has been skinnied down to just the pieces, which was the fundamental point of a lot of these embedded languages and these, a lot of these interpreted languages, was the idea of I shouldn't have to have much more, that it was essentially about risk thinking. A reduced instruction set makes it simpler to present the entire concept of what you're doing to people. Yes, you'll have more iterations, but the computer takes care of the iterations. You get the person to think of, how can I turn this into a set of steps and make those a set of steps in a logical way? And this is something we already deal with in life. We just haven't been willing to think of it that algorithmics is something we should be teaching in school. And the Arduino lends itself to this. We don't feel the risk, even if the cost for the equipment winds up being the same in the higher level languages. It's just easier to teach this. And of course, you can show, so one of the things is consumption, as I say, consumption has been standardized, which is from THX 1138. Even a knockoff Arduino Uno R3 is ready to work. It'll work, all the code's gonna work. You can show a point in the code where, that led directly to a problem, and vice versa. You can replace a resistor and show a new result. So I can sit here and take out one resistor, put in another, or I can even put in a knob and get different results. Or I can do that with the code and show, look, if I change these values, now look, both ways work. So you can teach both the electronic side and the coding side to get both parts of thinking out a problem and not being afraid of what are you going to break. They're resistors. They're meant to be, if you burn one out, that's success. That's a starting point. A light emitting resistor is the beginning of beauty. And the thing is, Arduino has lasted, even with internal fights, with the Genuino thing, and all of the other stuff that's happened. We're still making LEDs blink with these devices. Does that mean that one or the other has to go away? No. I mean, it's one of the beauties about this. We've got all sorts of ways to think about the problem. But it does lead to that I still, even with sitting down, you get stalled out going to that point, whereas the Arduino, I plug it in, I'm back to work.
We have thousands of ways to make lights.
Exactly. And so I don't even have, so whereas I've got an old school demo for you here, and I love the compactness of it, that I could power it a couple different ways. But I also know that I spend my world in Python much more of the time than I ever expected, considering I came into this from tech support. But now my world is moving more and more into scripting to help customers solve problems because they're talking to web servers, and everyone's world is talking to web servers. They're just doing it through their phones. It does make it fun to be able to show a kid that if you have one approach and then can switch to the approach of, okay, first you're going to learn how to write this. Now, why would you write it? Because, and being able to show from a phone, and every kid's got one now. And even when they don't, they can watch on their parents' phone. These are going to be different approaches. This future, well, it's here even if it's clumsy. And actually, it's not as clumsy as some of the stuff we've done in the past. And it's easy for us to forget how easy it is to, well, have some version of the internet somewhere to connect two pieces, to go get the information and get things going. At one time, we all remember 20 years ago, you needed to print out stuff. Nowadays, if you have trouble sleeping, you just take the PDFs and put them on your tablet so you can pass out to the crap you had to read. This is just as much as if you don't have time to put it on your work machine because of the restrictions, you bring the tablet with you. And it can be locked out too, but the point is it's sitting there with all the docs you needed. This is significant to trying to test things out, and it means that we've got these varieties of things we could be doing. So, the thing I was hoping to show you, because I wanted to have a demo, is what's it like once you've got it done? Do you have that power and efficiency? And that will have to unfortunately be next month, because I have decided it is important enough to buy one of these boards. I kind of want to support the people who have been doing the interesting work. And like you see, it's got the headers already on there. Do I love soldering? Yes. Do I have a 3-year-old and 2 cats and no time to actually solder? Yes. I will pay $5, because that's nothing. And of course, it's coming from SparkFun, so it won't take long. Although for some reason, it's a bummer because I've got a bunch of free money over there on my Amazon side. But 601, the price is cheaper by a lot. But it also means we have something else that we do not have in the Arduino world: external storage. We can address multiple things and have it switch into them. You can use the button to trigger different things, but you can it's got 2 buttons, one of which is a reset, but the other is an addressable button. And with having that just sitting there right on the Pi board, for example, you have the ability to switch out things that are happening, which would be pretty useful if what you want to do is kind of a demo mode, or you want something to have a couple of different projects going on and you just switch them like channels on a TV. This is not far-fetched. It also makes things simpler, like, Wi-Fi. I can update the equivalent of a WPA supplicant file and have all that info right there. Sorry. So that's where we get started. Next time, more to show you. But now I've talked too much. Questions?
It sounds like you're not totally thrilled with MicroPython.
I want to be more thrilled. I like, and I'm giving, I'm both giving, I don't even know if I'm giving it a full balance, because I do feel a bit Cassandra about it, because I want it a little more. I hate that we're still sorting out some of this first-time connectivity problem, because It is one huge advantage with Arduino. You plug it in. Thank you, USB. You plug it in, you get somebody going. You can start, and then you start rummaging through, hey, I found a TV outside. Guess what we're doing? We're playing with caps until we explode. Silly, but it means that you're moving directly into action. With this, I've got to do setup. Imagine I'm teaching a classroom. Imagine even just if all of us wanted to follow the bouncing ball. We'd probably have to have a starter session that's twice as long to make sure everybody's at ground zero. This doesn't happen with Arduino. Now, does that mean that we could not come to a point like that with these devices? No, clearly we could. The Pi board's only disadvantage is that built in, it doesn't have Wi-Fi. But it's got USB, so it's kind of like getting started with the Arduino. There it is. Plug it in and win. It's got the voltage. It's got an SD card. So if I want to preload them with, we're going to start by hitting the button and see what we got. Now we're going to read what we got.
For boards that actually support MicroPython and have Wi-Fi built in and don't have that heavy first start, Adafruit does sell the PyCom Wi-Fi.
Is that what they're calling that? Is that the next generation of the Huzzah, which was the first attempt to do that, I think? Yeah.
I think so.
Yeah.
It's all in their Feather board format.
Ah,
so
yeah.
it's, yeah.
So that's good. I mean, so...
Lua, I think,
Yes, the Huzzah was running Node MCU.
Because they actually talk about the Huzzah in the book I have about MicroPython. And I was surprised to find there are already other books about MicroPython. They're not even focused on the Pi board. They're focused on the language and moving places with it. So
Looks like the
Well, I was
Huzzah's
curious
just
if
on-
anyone here has actually used Lua.
I have.
You have?
Oh, yeah.
How's that compare? I don't.
So it is. So Lua's most famous use is things like World of Warcraft. Like you can build little scripts inside of other things because it's so small that it makes a great. Like for example, it becomes the addressable language inside an agent to something else. That because it's smaller than some of the code you're going to have for other pieces, you just throw it in. I actually know, for example, if you run, I'm in the world of monitoring, and a lot of people who are dealing with Windows boxes will use NS Client++ to monitor their machines. Inside the installable for that, they throw in Lua and a small version of Python. So, and it's actually, I will say, it is kind of fun because there are, one of its weird places that there are pre-built modules that do things. One of them's SNMP, which is kind of dated, but if you're in the world of monitoring, is like the dream come true. So like my product is built on, oh, you got SNMP stuff? Write it in Lua, we'll run it. Don't know your Lua? Don't worry. Piece, we'll do it. You want to look at what the Lua looks like now? Here it is. But it also means you can hand it right off.
Lua is pretty simple, straightforward.
Yeah.
You know, it's like basic. Oh, it's easier than basic.
Yeah.
Yeah, and it definitely runs faster than basic.
Yeah.
Yeah.
I was gonna say it's got a much simpler language than a lot of modern interpreted languages.
No
despite-
typing, no pointers, just
Yeah.
you know.
Well, I mean, neither does JavaScript. But unlike JavaScript, Lua really has very, very simple syntax. You
Yeah.
don't have a lot of crazy different like
Yeah.
even JavaScript now has like Lambda functions and stuff.
Yeah.
And Lua steps all the way back and goes, you don't need special characters. I think parentheses are the
Yeah.
most complex thing.
Because
in
you're
Lua.
dealing with, because they were dealing with the question of, we've got to make this work in Brazil. We're in Brazil, where they've got a couple of special characters in their language, but they don't want to be limited when they then export it to right across the river into Argentina, where they don't have a Sadia and they don't have Enyas on things. So they wanted it to be essentially what I call a Sicilian typewriter. No Ks, no Js, no Ys, no Ws.
What's really interesting is the level of simplicity that Lua provides has made it, as you mentioned, World of Warcraft.
Yeah.
You open just about any game that supports any level of scripting, they're going to be running Lua.
Yeah.
Just
And it means you don't have to write that language.
Yep.
It's there.
If you have
It's got books.
if you have a Canon point and shoot camera,
Yeah.
there's a hack for that loads in from the memory card every time you power it up, and it's just parallel firmware to go along with the camera. Adds all kinds of functions to the camera, and that's written in Lua.
Awesome.
I was going to say the
And it loads in the Lua
Yeah.
along with it. And it's
Oh, that's
tiny.
awesome.
It's tiny. you
Right.
know.
Yeah, and
The,
yeah.
It may not be a full feature.
Here, I can even while say your I'm going to find
I
a
was
file
gonna
while
say
you're
the
talking.
GoPro Heroes, up until version 4, had full operating systems running on them. When you loaded up software, one of the first available language was Lua.
Yeah.
So you could
Yeah.
you could do all sorts of interesting things with Lua on top of.
It's just, the interpreter is so small. for
Yeah.
what it can do.
Exactly.
That's the big advantage, I think.
And it's a huge advantage. It means there's so much you can hold in your head. That means you can get the entire thought out, even on a simple piece of paper, before you get too heavy.
It's kind of funny because a project I was working on a couple years ago, I started a backup.
Yes, yeah, they
I had
are.
stopped it because I couldn't find a small interpreter for what I was working on.
Here we go.
I was big on JavaScript and stuff at the time, and I started using Lua in Minecraft because there's mods that add Lua to it. And I realized I had started out trying to port JavaScript to that mod and be like, I want to use JavaScript here. And I realized,
Why are you down in the experimental branch, Dante?
What do you mean?
13616 is the experimental branch, if I remember my SMP right. 13614.
Yeah, because these are all made up.
Oh, okay.
So on purpose, yes. You know your OID and your MIBs. That's beautiful, man.
I wrote network discovery software.
Ah,
I could tell you what port a PC was connected to in a switch, what model switch it was, what card was there, how it was configured. We predated SolarWinds.
oh, cool. Yeah, I work at OP5. So all the people who got dumped by SolarWinds. But yeah, so yes, no, so that's why these are, because we were doing, this is learning this was just a trick for learning how to write trap handlers and stuff. But, I was just happy that I'm like, okay, the messages can be these silly things like phrases from Glenn Frey songs, and the Beatles. But the point is also that this shows some good examples. Here's just a comment. But notice, all you need to do to introduce a comment is 2 dashes. Awesome. Yeah, sure, everything has some method, but it also means you can, it's
Spaces matter.
actually,
Can I break the file by hitting backspace once at the beginning of the line?
nope. It doesn't care.
you'll see everything
That is
has
my
a-
biggest objection to Python. If
Well,
you open it with the wrong editor,
You're up the crick. Oh, yeah. Heck,
But
if you
again-
open it with a different editor on your same machine, you might screw yourself. Ugh.
Looking at this, besides mathematical operators, there's only 2 other symbols that you see in the entire language: dash dash and parentheses,
Yeah.
and that's it. There's nothing else. And I don't think Lua has any other symbols in it at all.
No, and if anyone really wants to know more about Lua, I actually have a copy of the Lua guide, but you can always get that online for free as well, because the Lua guys are very happy to promote without being obnoxious. What's his name? Yerusalemi. His name literally means from Jerusalem, so he's probably Brazilian Jew. That he wrote all this stuff, and that it's a great read. Like, you actually kind of enjoy reading it. It's a good manual. It pulls you along and makes you think about this stuff in simple ways. And they love the idea of, things become clear because you don't, like, I'm just nesting because it's convenient for me to read. I don't have to. It's not mandatory. But it doesn't have a problem if I do. So, there's fun. I think actually, maybe it does have some requirement, but not, I think it can be any kind of white space just to,
new lines, if you're not using it, you either need semicolons or new lines. But
Ah.
other than that, no white space characters are required.
okay, so that must be why it's going on. Okay, so it's using the new line for the job. So, cool. But yeah, so this just gives you some idea of what some of that can look like.
It's funny because the then and the end are kind of like curly braces.
Yeah, they should be all the,
'Cause
also,
they can go either new line or at the end of the current lines.
yeah. So, sorry, all the snurfles I
Do
got.
you know what the patent or copyright status of MicroPython is?
I do not, and that's a really good question. In theory, I think it's one of those GPL2 things, but because so many people are having fits about GPL3.
Micro.
Let's see. Good question. Very.
MIT.
Is there
Oh, it's
some-
MIT license. Okay, there we go. Problem solved.
GitHub's wonderful in that they tell you the license without you having to do any digging. You
That's
go,
true. It's right there in the.
MicroPython.
Yep.
MIT?
So
So.
nobody's gonna want money.
Nope. No. That part we're cool about.
And
Well-
you're allowed to distribute it and.
I was gonna say MIT means it's basically fair game for
It's a
whoever.
free for all.
Yep.
Yep.
It does mean if someone takes it, makes heavy changes to it, and re-releases it, they can charge you for the re-release.
Right.
But you just tell them to go stuff it and not use theirs.
Yep.
This is fair. So you can see some of these pieces. It's funny because the rest of my day this week has been about installing much more elaborate stuff. So it's kind of nice to get back to the small and realize how small I haven't gotten. Because I like the tiny machines. They're fun. And squeezy thing. I need to squeeze some more. Yes, my little squeezy light. So, any other questions for now, or?
I'm wishing I brought my board with me.
Yeah.
The ones we got, we had a gentleman, I think he was here too for a couple of meetings. And he brought in a whole set of baggies full of electronic component kits, and he just gave them to people at the Java group a year or so ago.
Oh man.
And it had in it a couple of the, I always screw the stupid number up, but the 8266.
Yep, that's the
Okay.
number.
And they also had a couple of the carrier boards. The carrier board, I think, actually said Node MCU, and I could swear it said Lua on the thing.
Cool.
I'm not using it for that. I mean, basically, I installed the add-in to Arduino
Right.
thing and just plugged it in and went to town. And I don't know whether on the firmware underneath it all it's Lua or what, but it works great.
I wonder if it
We were
is.
doing Wi-Fi with it. We were actually doing Blink from a cell phone
Cool.
because it was spitting out a web page.
Yep.
The little embedded device was presenting a web page with an on-off button.
And that is the beauty part of being able to watch this stuff from devices. Now that we all have these devices all over with us, it changes what we want to demonstrate.
And then Blixer and company proceeded to demonstrate why security might be important.
Oh yeah.
Might be.
As they wrote a quick little curl script.
Watch the cable.
They wrote a quick little curl script to emulate PWM.
Oh my.
Oh.
Yeah.
I forgot about that.
Oh, this was this month.
This one?
Yeah, it
This
was just
month?
a week ago.
Yeah, you weren't there, were you?
Oh, it wasn't.
I was
Blixer,
gonna
it was,
say no, because we did
Oh no
something like that.
it was
Darren
and company.
Yeah.
Okay.
Yeah.
I was gonna say because at one of the big talk events that happens down at OSU,
Uh-huh.
the first year we had open source hardware down there, we did something like that.
I wasn't there for that, but
Yeah.
no, I just I literally did a presentation on the 8266 for the Java group. Basically, the tie-in was we're going to build some sort of a home automation system with the Pi as the central hub, with some Java-based web services on it, and little remote sensor modules running this 8266.
No, security on these things is still going to be the piece that's. I mean, these things are going to be more secure than most IoT stuff you find out there, anyways. But
I mean, it does support WPA too.
Yeah.
But
Yeah.
not everybody knows wireless networks.
Well, we've got I was about to say, as sturdy as the cheap router you put them on. So yeah, no, I do want to make more happen, and probably of course, I say, oh, I'm totally going to get time. No, I'm not. I don't even know if I'm going to get time. I got not next week. So next week I'm like the rest of my company's gone and I'm still there. And the week after that I got to go to New Hampshire and do family stuff for my wife's side where I have to shut up and keep her from dying, and it's crazy and that's no fun and it's tough for her, and make sure my son doesn't explode because he's 3, and visit
that's the
other
thing
ones.
3-year-olds do.
3-year-olds are interesting. Right now, we're potty training him. It's gone really well. And as my mother pointed out, hey, he's half a year ahead of you. But moms, and I mean, to be fair, we can't wait to embarrass him when he's older, especially because he's going to put us into a nursing home and we have to try to escape from it. So got to plan ahead. But But yeah, I mean, there's all this stuff where you find out your son has a bladder of steel. He will get through the night, but the minute he realizes he's awake, run. And that's when you start thinking about, oh, we gotta like make it so he can get out of the crib. That's like adulty stuff.
Get him the big boy racing car back.
Right now, we have to get ourselves a replacement mattress because it's only 15 years old. I'm actually sleeping better when I sleep on the futon next to his bed. So when he yells, "Nah, you sleep with me," I go right in. I don't even flinch. I'm like, I'm gonna sleep like a log. I love you, son. It's louder. Yes, it is. So, yeah.
We're still recording, by the way.
Oh, yeah, good
Yes.
point. Yes. So, hey, I'm an embarrassing ball of things. Hang 10 in Hex.